want to introduce Daniel, and I'm going to talk very fast. Many decades ago, I was running a robotics contest, and it was the Friday before the contest, and I bumped into Daniel, and he speaks excellent English, but he had a slight accent. And so I said, "Oh, where are you from?" And he said, "Argentina." And I said, "When did you come to the United States?" Thinking he'd say 10, 20 years ago. And he said, "Wednesday." I said, "Today's Friday." He says, "Yeah, I just came here for the contest." So he flew all the way from Argentina to Hartford, Connecticut to come to the contest. And so I have been friends ever since. Daniel, it is your presentation.
Okay, thank you very much. It's a pleasure to be here again. I really appreciate your invitation. And I have a real mess here. So in the last 2 minutes, I had to rearrange the whole presentation. I had really trouble here, I'm going to tell you now. How much time do I have, Jake, please?
Unfortunately, you have about 10 minutes.
Okay. The last presentation I did last year, I used the example in working on a printer, an old printer, a laser printer, and we made a complete unassemble of a printer, trying to show people how many good quality pieces we could take out of any equipment, especially if the equipment had more than 10 years, because it used to use better material and stronger, much more robust. Now, in this second presentation, my intention was to show what have we been doing with our pupils with those materials, or some of those materials. Unfortunately, I will wait until the end of the 10 minutes to show you, because the software stopped working together with Zoom and the camera. Everything went crazy. So I'm working with another computer talking to you while I try to turn on the rest of the system. Now, the main idea was to build a CNC. The CNC, of course, has no high precision still, at least, because we don't have that that practice with my children. But we did work with the X and Y axes just to show how the movements could be controlled. In order to do that, we used the platform, or the base, the structure of an old laser printer, because it's pretty sturdy. It's really strong. Let me see if I can get this now. Okay, and based on that structure, we started with some wood, working around, and we made an X-axis using steel, very good quality steel axis, 6 millimeter diameter for the X-axis, and another one for the Y-axis. Then we use normal threaded rods, not special for CNC, because we try to work with the concept, with the structure. Now, the main point of my talk today is showing the machine. I will try to do that at the end of my 10 minutes. And also make a point in that what we notice here in Argentina, probably this happens all around the world, is that children are not using their hands properly. They're not making much hands-on activity. Usually, most of the activities are with computers, softwares, touch screens, keyboards, etc. I know that's a modern society, but we still believe in that they have to use their hands and their ability and use their knowledge and try to build new knowledges, as the constructionism says. And these practices are really good because they get very enthusiastic about it. At the same time, very inexpensive, because you use old materials that usually are being thrown away by other people. Let me see 1 second, please. Well, also they're going to work with a lot of tools like hammers, saws, and screwdrivers, and power tool screwdrivers. Try to work with the square. I'm trying to say this. Making things square, 90 degrees. I know it will never be perfect, but it's very different when you have some skills and you use them than when you start building just a piece of wood. Well, you have to work with that, because the first experience was to build it in 3 hours, and then the mechanism did not move, because all the forces that were involved in this non-squared cuts just did not allow the motors, the stepper motors, to move. By the way, Jake, let me show you. Let me see if I can show you now. 1 second, please. Let me see. I have here the camera. I'm going to share. Can I share the screen with you, Jake?
Yes, go right ahead. The green button, share at the bottom.
Green button on the bottom. Well, I think I don't have it, so I'm not going to share.
You may have to scroll your cursor over it to see it.
Okay. Oh. Okay, I lost it. Can you still see me?
Yes?
Okay, I lost your image. This doesn't matter. I'm going to just continue. Let me see. Blue one. I got zoom. Okay. Okay, yeah, I got it. Sorry. Okay, there we go.
There you go.
We see it. Now we see what you're sharing.
Okay, right. Well, am I still sharing it?
Nope,
No.
you lost it.
Awesome. What can I do? Sorry, already. No. Well, okay, I'm going to try last thing. I'm going to try to show you with my computer. Now you can see it, right?
Yes.
Okay. You can see at this point, I have a stepper motor up there.
Yes.
Okay, do you know where that came from? You know, right? From Connecticut. It's the first project we'll be doing with your motors, and it was we wanted to adapt it to use those motors. We wanted it to be part of our first CNC. Okay, so now we're working online, 100% online. We don't have the freedom here in Argentina to work at schools, or maybe schools, yes, but not with an unofficial institute, as I do with robotics. So you must know that teaching robotics online is very difficult, very difficult. ¿Me regosito, por favor? Está clavada, ¿no? Sí, baja un poco. No, está clavada, Matías. Well, I suppose I'm running out of time, Jake, so I won't be able to show the machine. Now, let me tell you this. Each child of my group is about 5 or 6 different people, each one at his home. Each one of them is building one of these machines with their wood, with their motors. So I'm building this with their ideas. Every time they come up with an idea, I put it up in the machine. If it's not possible, I try to explain why not. And if it is, we work on that, doing all the theory. So at this moment, we have 5 or 6 of these machines working more or less the same thing. And let me just tell you that the success was when last night, just before my presentation, we managed to do this machine to do a circle. Until yesterday, or the day past yesterday, it only did one straight line, only the x-axis. Now, it's not really a circle. If you know, it's a little elliptical. We still have precision problems, but it does make a circle. I'm going to show you on camera the only example we had.
But Daniel, let me tell you something. This is very interesting, and we have an interesting opportunity. Your slot is going to end in about 1 minute, okay?
Yes,
but
yes.
We have an empty slot at 7:45 Argentina time.
It's mine.
7:45 Argentine time. You can have another 15 minutes. Okay. So you've got some time to get everything set up and come back.
Great. That's a beautiful opportunity. 7:45 now, right?
7:45 your time. Excellent.
Thank you very much. Thank you very much. I'll see you then.
And buenos días, Daniel.
Hello. How are you? My second chance. Should I start?
I think you dive straight in, yes, when you're ready.
Okay. Everything went wrong an hour ago. Everything is working okay now. I'm going to start showing a video. I'm changing the order just in case something fails again. So I'm going to put a 1 minute 50 seconds video. Then I'm going to show the result. That should be the last shot, but I'm going to show it first. And then I will explain the process we had building this machine. Okay?
Perfect.
Okay. Just let me know if you can see this properly. You have the screen.
We can see that.
1 second. I think we have. Now, okay. Just watch this, and I'll talk in a moment. Okay. Play. Well, I will keep on talking just in case. Our intention is, this is an old video. We already showed it last year. Unassembling all machines to pick up all the pieces we could take from them. Now I'm going to show at the end of the video, about my presentation, sorry, one of the results. First intention, the kids should see every part inside the computer, probably explain how it works, but most of all, what does it look like, what kind of a material is it, and how can we take advantage of it in our own inventions or applications. The main goal at the beginning of this was to build a CNC machine. So the first thing we did is, well, unassemble the machine, see the pieces. You can see gears. Mostly we're going to use axles. Some, I think the name is bushes, something that you can move. You put the axle inside and you can just smoothly move it from one place to the other. I think it's called bushes. I'm not sure. We call it bujes in Spanish, in case somebody wants to translate. Our second stage would be to get the kids to build something with their own material, whatever they find out, even carton or wood or metal or plastic, whatever they want. Once they find out that it's very difficult, I always remember a phrase from a sentence from Jake. After explaining the whole thing about competition or robot or whatever, he said, "Welcome to the real world. Welcome to the real world." Well, when you realize that, you'll find friction, you'll find angles that are not right angles, and a whole lot of problems that make your project apparently preliminary fail. That failure is going to teach us a lot, of course, especially to kids. And that's when I started offering these materials, like the one you can see now, an axle. It's a really nice steel axle. I think it's 6 or 8 millimeters wide, diameter, sorry. So now they're going to get those old materials that were salvaged from a non-computer, but really with an important need. They will need this to work out because they work much better, and at the same time, they're almost, well, very, very cheap, almost $0 pesos of investment. So once we get the good materials and we teach them how to build it, first, they already saw materials not so precise, with so much precision, sorry. After that, they build it up. They still don't get good precision because they have to learn how to build with it, how to take advantage of the materials, how to work with some tools. And it comes out something like what you're going to see now. I'm going to show you the first machine they built. And at the same time, show you it's not still good precision. Now, for a couple of months, our job is going to build another machine with all these techniques and materials, but getting more advantage of the precision of the pieces, making the machine with good movements, having nice precision, and if everything works okay, it will be a CNC where they can, I think it's called to mill. They will mill a PCB. What is a PCB in English? Printed circuit board. Printed circuit board. That's it. Okay, let's see then. I'm going to unshare this for a moment. I'm going to try to share this one over here. Okay. Jay, can you see a white page here? A white page of here?
Yes, yes.
Okay. Now, this is, I'm going to show you after some details. This is the CNC, but it's just the camera is aiming straight to the paper. It's not a very high quality result, but it will work a circle where we're working with 2 axles, X and Y. As they're not completely with a good precision, they will draw something near a circle. And the Z axis does not exist yet. So there's a pen already put on the paper. So going to the starting point of the drawing, you will see the line going there because there's no Z control. So the pen will draw the whole track. Okay. Okay. There we go. This is moving, the whole table is moving in order to make an x-axis, and the pen is mounted on something that I will show you afterwards up here. There's a y-axis over two 6mm steel axes that came from the printer. Should be drawing. Here you can see the other axis, one, the other one around there. And we got something that we could barely call it a circle. Where's this part? I don't see a number.
Pues, puedes decir cuando termine. Se va a apagar.
Okay, even though it's just a circle and it doesn't really look completely like a circle, it's a complete success because they managed to build. We're not using a self-built program to control the CNC yet, because it's much too difficult when we're still starting to build it up with some precision, make it useful. So now we're trying to show you with the camera. Well, I already told Jake about this stepper motor. Okay, Jake, here you got the other stepper motor over here. You know those. Now you can see those two axes. Let me see where it looks better. Here. This is a normal threaded rod, the ones in the middle. The other two are those axles brought from the printer. And these pieces over here, I don't know the name for them, but they move really smoothly over those axes. They have just slightly, very small little play, still acceptable for today. In the future, probably we will replace those for something made by steel or iron, something a little more precise. Now, anyhow, to be the first one, it is 99% completely square. They work very much on that point. And that is really important for me because, as I told you an hour and a half ago, one of the main problems I found, let me share this. One of the main problems is that I don't notice that kids today can work properly with their hands. They do not know how to use a hammer. So I cannot pretend them to cut with a saw or even using a tool in a really straight angle. They must understand that things sometimes need to be almost perfect, or not completely perfect, but until an acceptable point so we can build an important machine. Today, this machine draws and it's really a success. We're aiming to build up all their skills in order to get this moving to 1/10 of a millimeter. 1/10 of a millimeter, and that will allow us to build PCB boards with a high precision and a really complex circuit on it. That completes my presentation. I'm sorry I failed the first time. Now I feel more tranquil because I could think of what I'm talking about.
Very good, Daniel. That was excellent. For those of you who've never done anything like this, making a vertical or a horizontal line on the paper is hard. Making a diagonal line is even harder. Making a circle is really hard. So don't worry about the quality of the circle. The fact that it's curved is very good. That's excellent. That's excellent.
Okay. Thank you. I think this is very useful. I know you think like me, we're talking a whole lot of people. I think we have to build that in the kids, especially when they start early, because there are not many activities nowadays. We need to look for more activities that force them to do hands-on activities, and not only to think. Of course, it's very important. You have to think, and they also build some manual skills playing these games on the computer. But if you have to build a machine and make it work and move in 3 dimensions and make it move properly and go to a competition and turn out a candle or whatever we can do, well, they need to practice that and learn it. And they will not study engineering probably in the future, but it helps them to learn, to think, to solve problems, always playing, because this is like a game. And if they go to a competition and win a prize, that's better, but it's not really the main aim.
Right.
Children to think and to solve problems.
I think the problem, Daniel, that you have, and frankly all of us have in this, trying to do this kind of activity, is it looks like it's very simple. If you say to the students, oh, we're going to build a machine and we're going to draw a straight line or a circle, they think that's not very hard. And then they start to do it and they realize how difficult it is and how many variables and how many issues pop up. I think that in itself is a learning experience, just to realize that even simple things are not very simple.
Well, let me tell you two more things. I think I still have a couple of minutes.
Yes.
First, this took about 6 months of work. And when you see it, it looks like something simple, really. I copied, this machine is in my house. Every one of the kids have one of these similar in their house. And I kept on building only what they did. I didn't do it precise and good because I did. I just did what they did at their home and tried to reflect the same machine. It took more than 6 months. And let me tell you that I suffered this for the first time before getting married with Patricia, you know her. And I had one of the first shocks at life of being married or having a girlfriend or whatever. I had my Commodore 64 for the first time, 64K computer from Commodore. And my father brought it from the States. And it cost me a whole lot of money. Had no disk drive, no hard drive. And I started working on a ping pong ball that just bounced back and forth, straight, with no angles, only a little ball. It took me about 3 weeks, maybe 4. And those 3 weeks were 3 weeks when we did not go out because I was working all the time. I had the university and my activities and also this game I was preparing. So finally, when I finished, my girlfriend, my fiancée, came to my house to see my great job. So she looked at the screen, the ball bounced one on the right, back to its left and back and forth. And she looked at me and said, "This is all, that's all. It took a whole month of not going out for this." Well, that was my first experience, first frustration in life. Now she's my wife, we have beautiful kids, and I'm really happy. But it was hard.
Very good. Well, thank you, Daniel. That is very exciting. Now, here's one thing, though. I'm going to give you an assignment. Next time, we're having another gift in October, and I would love to have some of your students present. Have them talk about, and they don't have to show something that works. It doesn't have to work, but I want them to gain the confidence and the experience and realize that people around the world are interested in what they are doing.
Okay, can that be in Spanish?
Of course, absolutely.
Okay.
Absolutely. Just so you know, Daniel, we had a whole group of incredible students from Mexico who were here earlier, and they were giving presentations in Spanish. So it's absolutely perfect. No problem.
Yes, I lost them. I missed them because I was fighting here with the computer. I wanted to listen. I'm going to see the video when you post it up.
Yes, well, it'll all be recorded, and you can look and absolutely connect with them. Absolutely, that'd be fantastic.
Okay, great.
Okay,
Great.
excellent.
I accept the assignment.
Okay. It's been recorded. He has accepted the assignment. Thank you very much, Daniel.
Thanks to you for my second opportunity. Now I feel much more tranquil. Thank you, Jake.
And if you need more stepper motors, let me know. You can come and get them anytime you want.
Okay, just around the corner.
Okay.
Thanks.
Thank
Goodbye,
you.
Jake.
Bye-bye.
Bye-bye. Bye, everybody.